everyone. So as I was introed, my name is Dan Norris. I'm the infrastructure lead over at a company called Cosmonic, and we'll talk a little bit about what we do and who we are. But today I'm here to talk to you about zero downtime deploys with Temporal and wasmCloud. So to kind of set the stage for what we're going to talk about today, so I'll chat a little bit about who Cosmonic is, what we do, where WebAssembly comes into play. I'll talk about why that led into Temporal and kind of our adoption of it. I'll talk about the workloads that we actually use for managing our infrastructure, since that's primarily what we use Temporal for. I'll talk a little bit about how we've started to integrate Temporal with actually our Rust code and Rust platform, and then I'll end with some key takeaways. Got a little dark in here, but I'm kind of curious, show of hands, who has actually heard of WebAssembly? Okay, most of the room, that's awesome. Follow-up question, who is using WebAssembly? All right, much fewer hands. Back end or front end? Back, okay. Interested to talk to you. But anyway, so Cosmonic, we're a pretty small startup. We're basically building a platform as a service for running WebAssembly applications in the back end. There's a lot in there. This is in a WebAssembly talk, so I'll spend just enough time talking about what that means in a little bit. But specifically, what we are kind of built on top of, because we aren't running on WebAssembly and is kind of this new novel thing, is we are actually running on Nomad for our orchestrator as opposed to something like a Kubernetes. We're on Amazon, so we're all kind of in the cloud, right? And a lot of different things went into that choice. Specifically, that allowed us to run our customer-facing workloads as Firecracker VMs. Actually, we've given an entire talk on that actually at HashiConf last year. So if you're curious, check that out, but it's kind of a little bit of a digression. But what we found is that actually poses a whole bunch of kind of tough problems for us to solve as an infrastructure team. By the way, I am half the infrastructure team at our company, so a lot of different things that kind of me and my colleague manage. But because what we're doing is sort of so bespoke and honestly kind of so cutting edge, we needed to figure out how we actually manage all our infrastructure in a sane way. So cue Temporal, because that was one way we ended up solving it. And specifically, what we do is we're built around a cloud-native sandbox project called wasmCloud. And what it is it's an application runtime for running WebAssembly on the back end. We kind of think of it as like, not to be too buzzwordy, but like a compute mesh. You kind of basically run a bunch of WebAssembly individual modules and link them all together using NATS as a transport. NATS is like a pub subsystem. We'll talk about it. And so the advantages to doing it that way are you get the extreme portability that you get from WebAssembly because it can run anywhere, browser, pretty much any OS, pretty much any hardware that you do, since it is a virtual machine, very similar to something like a Java. But you also get sandbox security, and pretty much every language on the planet nowadays supports WebAssembly as a compilation target. So it's really portable, it's really secure. There's a lot of good stuff there. The core of what we do is actually written in Rust. There are SDKs right now in Rust and TinyGo, which is a variant of Go that's specifically for embedded. But now with a whole bunch of churn and evolution in the WASM space, we actually can pretty much run with any other language, so that's pretty cool. And it's compatible, but not really dependent on like Kubernetes or containers, because it can kind of run anywhere. And so this is kind of just a rough diagram of how things fit together. And the reason that I'm kind of going into a little bit of depth here is because what's here, and specifically what's within that green box, we're going to talk about in terms of temporal workloads in a little bit. But at a high level, what's going on here is this is what a customer workload looks like to us in our platform. So customers run WebAssembly, we call them actors, like very much the actor model, if you're familiar with that, which are little bits of logic. They can be big, they can be small, it kind of doesn't matter to us, but they are self-contained. And one of the properties of WebAssembly, and up until very recently, is that basically they can't really communicate it from the outside world. So what wasmCloud allows you to do is when an actor wants to make like an HTTP call or talk to a database or key value store or anything like that, it actually makes a request to what we call a provider, which allows it to bridge that gap. And NATS is sort of mediating and being like the transport between that. So keep that in mind. Basically, everything within the green box is going to kind of come up again in a little bit. So just like mentally snapshot that. We'll talk about it in a little while. But basically, there's an entire talk and give basically on all those components. We're not going to do that. We're going to go back to talking about Temporal. So why did we decide to actually go with Temporal? So as an infrastructure team, especially as a very small one, running a actual platform as a service, we have a whole bunch of sort of maintenance tasks that we need to do either day to day, week to week. So things such as updating virtual machines, like EC2 instances, updating various parts of our platform that happen to run as containers, our customer workloads, things like that. And we want to do that in a way that minimizes downtime and ideally has zero downtime both for us and our customers. And so using Nomad in particular as an orchestrator solves that for us, very similar to, I imagine, anybody who happens to be running Kubernetes for your infrastructure. Same idea. By and large, that helps us in a lot of different ways, like various third-party dependencies, things like NATs in particular, stuff like Vector, which is how our observability pipeline works. It basically collects logs and metrics. And also all of our control plane services all run on top of Nomad. So we already have the capability to sort of swap things out at runtime, and that's all fine. But the harder parts, of course, of that are things that are a lot harder to automate. So actually swapping out the underlying virtual machines that are our entire infrastructure, also replacing the core components that we depend on. So things like Nomad Console Vault that don't really run as containers. They're not being supervised by Nomad. So we have to actually swap that out and in a way that doesn't bring down the rest of the system. So clearly, it's why we're automating all this stuff, because it's hard. And so what we ended up doing was we built some workflows that actually helps us to automate all of these error-prone operations and things that you have to deal with while being in the cloud. So what we found was, and I've actually worked with Temporal before this job, so just FYI, we kind of were not starting completely from scratch, but what we found sort of from going through all of this was that Temporal's runtime model is like a great fit for managing infrastructure, right? It's fault oblivious, you can retry pretty much forever. Things like swapping out EC2 instances are long running, and so Temporal just like naturally handles all that pretty much for you out of the box. And so like our platform is built in wasmCloud. Like we could have eaten our own dog food a little bit more and kind of tried to do something a little bit more workflow-like, but honestly, like why would we do that? Temporal is pretty great. May as well just leverage it. So we'll talk a little bit about now sort of like the individual workflows and sort of how we ended up solving some of these problems for ourselves. And so there are three primary workflows that sort of come into play, at least from managing our infrastructure. So we'll dive into each of them, but they're upgrade server, upgrade host, and upgrade provider. I'm not very good at naming, so they're all real literal. So upgrade server is the first one I'll talk about, and it's exactly what it sounds like, right? It is a workflow that goes ahead and upgrades a single EC2 instance. And it does this by actually rolling out a AMI, so an Amazon machine image, to replace a single instance within an auto-scaling group. So progressively, we will go through and run this a couple times. And at the end of the day, that auto-scaling group will have the new software. And so the individual activities that we sort of have within this workflow, right, are, again, fairly straightforward, but we basically go ahead and we figure out the EC2 instance ID, which is derived from the Nomad node ID. We can do a lookup there. We go ahead and we drain that node. We replace the instance by terminating that instance and waiting for the new one to be replaced. And then we do a little bit of cleanup back in the Nomad backend by just deleting the node so we don't have to think about it anymore. So what's nice also about Temporal is that, this is a workflow, right? I pretty much just told you exactly how it's working in sequence without a whole lot of detail, which is kind of a nice thing when you're talking to anyone external. So the hardest part of writing this particular workflow really was just the process of replacing the instance, right? And it's not actually hard because replacing instances is actually pretty easy. It's mostly just an API call. It's mostly the ceremony of actually waiting for it to come back. It's waiting to make sure that it's terminated. It's the retry loops of like making sure that when it's ready, it is actually ready. Most of the time you'd use something like, like a Terraform, right? That's the whole reason that tool exists. But being able to encode that into a workflow and in activities in particular was pretty convenient because all of that is stuff that we don't have to think about. Another thing that we figured out sort of through this process is that heartbeats are a great way to report status of some of these long-running things, because you can actually, so every workflow basically sends a heartbeat periodically to be like, yep, I'm alive, temporal server, like things are going well. And so you can actually attach status to those, and then you can query them on the other end. So it's kind of convenient as you're waiting for things to be like, oh no, it's still going, it's still doing its thing. Just as an operator, it's kind of nice to see that every so often. And so the other workflow I wanted to talk about, to shift gears a little bit, is our upgrade host workflow. And so hosts, as kind of a reminder, is that green box that I was talking about before. And so those are actual customer workloads, right? So our problem there is that since that's actually running customer code and customer logic, we don't want to just like kill them, right, without actually having something else running, ready to go and running their actual application, because otherwise the customer is going to incur downtime. So what we do is pretty much we just instantiate a whole other duplicate host. We do the migration. We make sure 2 copies are ready to go before killing the old one. And so implementation-wise, this is actually a workflow that creates other child workflows, a singular upgrade host for each one. And we found that's a pretty good pattern just in general. You have to be careful. We'll talk about some of the caveats. And the reason you have to be careful, right, is because of event history. So if you've been doing Temporal for a while, and especially if you read a lot of the docs, it's pretty upfront that there is a upper limit to how many events you can run per workflow. Temporal will start warning you every about 10,000 events or so. And at about 50,000 events, it will kill the workflow. So you do have to be mindful of your event history and not blowing it up. It's not hard to do, you just have to know how to handle it. So there's a construct, you can basically terminate a workflow early with continue as new, which effectively just instantiates a new copy with the event stream basically just purged. So this workflow is interesting because we had to account for that pretty much up front. Basically, it has a couple of optional parameters so that you can invoke it with a smaller subset of hosts. So that way it can keep churning along and doing work and make sure that everything's good to go. A good example of this, so we write all of our workflows in Go for the most part, just FYI. But the samples Go repository has a pretty good example of this. So if you wanted to follow along and kind of like see what it looks like, there's a pretty good resource there. And the other thing that we figured out what we needed to do was actually, when we create the workflow, we needed to set some sane defaults for the most part, so that an operator who invokes this workflow, if you forget to give it a parameter, right, things should just like work out of the box. So some people actually talked about doing automatic generation, like code generation for some of this stuff, which is actually awesome. I never really thought about that. I just have a function that I call right at the top level of this workflow that goes ahead, and if you forget, for example, to set concurrency or how many hosts you want to upgrade in parallel, right, it sets it for you. Same with setting an upper limit for how many hosts you can do before you get to a new workflow. And also it instantiates and keeps track of any that may have failed so that we can, an operator at the end of the day can take a look and try and dig in a little bit more outside of the context of a temporal workflow. Other thing that we found useful was actually adding in a query handler is helpful. That way you can kind of just invoke or set a call to the workflow itself to see how many more hosts you need to upgrade, so you can periodically check it. So like if you're like me and occasionally running this stuff, you want to see how long you actually have to wait till it's done. That's pretty convenient because you can just do that through the CLI. Another hard part we had to figure out here was because we're talking like possibly thousands of different hosts to sort of run here, and we don't want to do it sequentially, is how do you actually go ahead and concurrently manage all of these workflows in Go? There weren't really like super great examples that I could find, at least in the samples repo. So what we did is basically just the first thing that it does is it goes ahead and collects this list, right, and then partitions that up into a bunch of not really Go routines because they aren't really supported in Temporal, but like there's a construct for that. And again, we just make sure that we keep an eye on the number of hosts to make sure that we don't exceed our event limit. And so for an individual invocation of like one of these child workflows, we basically just give it a host ID. And what's cool about this, at least from our perspective, is we'd already written a bunch of code that like knows how to do the migration and that can handle kind of a lot of the internal details of it outside of Temporal. So really, Temporal ends up being, at least for this particular workflow, more of an orchestration platform for actually managing calls into our backend system. And that's all mediated by NATs. So other people may use Kafka, Rabbit. There's all sorts of pub subsystems. But it's kind of nice because the activity basically can sit there and subscribe to everything and just kind of wait and then continue or fail or deal with whatever happens from the workflow based on those responses. So it makes it pretty flexible for us because we can kind of slowly introduce Temporal where it makes sense and leave the code alone until we're ready to sort of migrate it either further into Temporal as like dedicated activities or just leave it as API calls. It's kind of up to us. And illustrated a little bit better, here's just a quick diagram of kind of what that back and forth looks like. So within the context of a worker, within the actual workflow and the activities, right, we actually instantiate a NATS client that just sort of waits on a particular, or rather it subscribes to and publishes to a particular set of subjects or topics. And that basically on the other end, our APIs are sitting there waiting for those invocations. And so they do their thing and submit all the progress back. So NATS just kind of mediates all that. It's kind of built into everything, so it works for us. The last workflow I wanted to chat about was our upgrade providers. So as a quick overview, providers in the context of wasmCloud is just a construct that kind of the framework gives you. And what it does is it binds or links to a particular wasmCloud actor, which is like a compiled WebAssembly module that exposes various capabilities. So this is the stuff that makes WebAssembly useful. Like it lets you actually hit a database, it lets you make HTTP calls, whatever you want to do, and that's mediated by one of these providers. So because we're a hosted platform, because we kind of are trying to make lives easy for our customers, we manage a bunch of these for them. So we hit the problem of like, well, how do I roll out new versions of this? How do I upgrade them? How do I deal with things like that? Typical kind of operations nuances. And so, of course, the answer there was just another workflow. Structure of this is pretty similar to upgrading an individual host, right? So we kind of collect the list of all the hosts that happen to have this provider running. And, we start a child workflow to sort of actually do that and carry out that operation. We collect things, it reports status. Similarly to the other workflow, we have a singular version that actually does all the real work. So it queries the host itself, and then if it actually happens to be running something that needs to be upgraded, then therefore upgrades it. And again, this sort of, the temporal activity is more interfacing with some of the lower level bits because it knows how to talk to the control plane via NATS because it has a NATS client. So it's an easy kind of shortcut to kind of integrate in with what we already have. What's also cool about this is we also, we store all our secrets in Vault, HashiCorp's kind of secrets management product. So we're able to instantiate a client there to actually, that the workflow itself can use to talk to everything. And honestly, just like being able to sort of do all of this in a language that we're familiar with just makes it so much easier to write these workflows. Some lessons that we kind of learned as we were going through and doing this is that temporal workflows are not really native code. They kind of look like it. They kind of feel like it. I think most of the SDKs do a pretty good job of sort of hiding that from you. The Go one is a little more upfront about it, right? There's things like iterating over a map, which is like the classic problem. I think even Sergey talked about it. I don't think with maps. I think he talked about things like doing more side effecty code that made things non-deterministic. But map iteration is non-deterministic out of the box in Go. So if you want to do that, you have to basically save all the keys into an array, sort them, operate on that instead. There's a couple other constructs there that you want to be careful with. So one thing I would love to see, and maybe we can talk about this maybe in offline or in the temporal Slack, is I'd love to see design patterns, right? I think all the various samples repos are great, like in terms of teaching you sort of where all the features are and what they look like. I think it gets a little harder when you're like, wait, I just want to write this workflow and I kind of know what I want to do and it kind of looks like this one, but I don't really know kind of like how I should really use this. It'd be great to collaborate and have a library of those. So just something that might be fun to talk about at some point. I'm actually going to skip that slide. It's not that interesting. So that's basically all the workflows that we have. And what I want to talk to you about to kind of finish up is actually how we called into Temporal from Rust. So we are actually mostly a Rust shop, primarily because of the WebAssembly stuff. But the actual scenario that I kind of run into is sort of like as I was sort of teaching people how Temporal works is the interface is tctl. Totally fine, great tool. We also happen to pay for Temporal Cloud, but what we discovered, and you kind of know this if you tried it out, is there's a lot of command line options you need to do if you're actually like invoking workflows manually as an operator. For example, with Cloud, you need MTLS certificates to actually be able to communicate with Temporal's hosted product. And so that's kind of a pain. It's not awful. We wrote a shell script around it. But if you look at this, right, that's what, like 6, 7 options before you actually end up running a command. And so this run tctl is that wrapper I just showed you. But then you have to do like workflow start, give it a workflow ID. That workflow ID may not conform to anything interesting. Then you have to know what allowing a duplicate means. Are there ramifications there? What's the task queue, right? All of the stuff to people who do Temporal day in and day out is kind of second nature. But to people who are just learning, or it's like, I just want to run this one thing, it's kind of not great. So I had an idea, because we do everything with nats through PubSub. What if we just exposed it through nats PubSub? So that long command, which is in a wrapper in a shell script, turns into something a little bit more consumable. Nats request to a particular subject, in this case, Cosmo.il, which is like an internal identifier, host.upgrade, and you can give it JSON as parameters. That just invokes the workflow and through Rust, which I'll show you in a bit. To actually upgrade a host, we give it basically the same sort of format. You just give it a dedicated host ID, and then no parameters, and things just work. And to upgrade an individual server, you just give it its Nomad identifier, right? No parameters, things just work. So we found it was a lot easier for other people who are not on the infrastructure team to sort of like actually be able to interact with this stuff and be able to make changes when we kind of need to. So how this is all implemented, right, is that we have a wasmCloud component that is listening to nats, so it knows how to take that information, information from the subject and whatever parameters, and actually invoke a workflow. And because it's in our backend, we write Rust. We're actually using a Temporal client actually instantiated from the core SDK to invoke a workflow. And so caveats here, right? We're only using the Temporal client, and so like that's very well supported. That's how all the other SDKs work. What we found, the actual hard parts were not really that hard, but it was mostly kind of messing around and trying to figure out which types you need. It's not really documented as something that most people need to consume. That's a pretty common Rust problem though. Also, it's a little verbose, right? So it would be great to have an official Rust SDK, hint, hint, to actually be able to implement workers and activities at some point, because we would use it. And I imagine with some dedicated time, right, you could probably smooth out some of the things and make it easier for actually interacting with Temporal, even from the client side, and just wrap it. Oh, hey, my slide disappeared. That's fine. So key takeaways. So what we found was that Temporal was great for our infrastructure workflows because of the strengths inherent to Temporal. Also because it was able to, or we found it really easy to reach out to our existing systems or to third-party systems like Amazon or our internal stuff, right? Just made it really easy to actually start encapsulating these things in reusable workflows. We can use kind of quirks of the workflow SDK to make writing our workflows easier, particularly in Go. There are upsides, there are downsides there. And then we also found that the client worked really well for us in Rust. Oh, there it is, it switched. That's all on me. Sorry about that. This is actually what the Rust code looks like. My bad, I hit the right arrow key too quickly. So just to kind of wrap up real quick, this is what it looks like to invoke a workflow in Rust. It's pretty straightforward. If you've ever done gRPC, this should look syntax aside pretty similar, right? We're basically giving, creating a parameter struct. We're then kind of translating that into a payload, which is just an SDK specific thing. And then here, because this is all wrapped up in code, the actual workflow invocation or the actual name of the workflow, right? I'm able to sort of encode in code so no one has to think about it. But then, we start the workflow, we give it the payload, task queue, all that other stuff. And then at the bottom, which is not on here, we handle, did it work, did it not work, do we handle our errors, etc. So again, this is basically all kind of what actually the underlying Rust core SDK is doing. We're not doing anything interesting here because we're not actually, writing a worker or anything, but it's fairly straightforward, it works. So happy to chat about it online or offline. And yeah, that's it. Now you actually saw what it looked like. So that's pretty much what I had. Questions?